Right boys, today we're going to look at some exothermic and endothermic reactions. And basically all that is just telling us, do they release heat, do they make heat, do they absorb heat, do they feel hot, do they feel cold? And it's quite a common thing. It's a very common thing for experiments to get hot as they're working. Very often they release energy. Here we have an example. This is a substance, looks like water. It's called hydrogen peroxide, and if you see the temperature there, the temperature is, I'm guessing, somewhere around about 20. Yes, it is. Oh, it's chilly actually. It's more like about 10. Does it come from the fridge? Apparently that has come from the fridge. Okay, so it's about 10. This stuff here is a catalyst, and it's a catalyst called manganese dioxide. Now, manganese dioxide is a catalyst. It will speed up a reaction. If you leave this to itself, it'll go all bubbly. Takes a long time. That will make it go much, much quicker. So let's pop that in there. Remember, 10 degrees. What happens? That is crazy, some sort of Harry Potter stuff. It's literally magic. And that, you can't feel it, but that is hot. That is extremely warm. It's gone from 10 degrees and it is now up at its, instantly in a couple of seconds, it reached 75 degrees. That's called exothermic. It has released heat. The heat has exited from the chemicals. It is now very hot. Right, this is another experiment, and this is the reaction of salt and ice. Now, ice out of the freezer, it should be probably, I'm guessing, round about -1 degrees. It shouldn't be too cold, but it should be something like that. If we look there, yep, we are looking like about -1 degrees. Somewhere there. Now, let's see what happens. Load of salt. Plenty of salt, chuck it all on. Mix it all around. If you listen, can you hear some creaking or something? Let's mix it up a bit. Mix it all around. It's starting to stick together. Get some more salt in. Let's not mess about. Whoa, that is cold. I'll tell you what, I'm touching those ice cubes and, well, I can barely touch them now. They're not getting hot, that's a fact. Oh, I can't hold those. Too much, too much. Let's take this out. What have we got in there? What is that temperature in there? We are now down to, oh, my fingers are killing. That is -11 or something. -11 degrees. That has dropped, it's straight away dropped 10 degrees. And if I leave that there, it might go down a bit more. Now, what you've got there is what we call an endothermic reaction. It's the opposite of an exothermic reaction. Heat has left the surroundings, it's left the tray, it's left the atmosphere, it's left my fingers, and it's gone into the reaction. That's got cold. The chemicals have absorbed all the energy. And I tell you what, my fingers are killing now. They are really sore. I wonder if it's gone down any more. If I can quickly look at that. No, not changed much. It's something like -12 degrees or something. Well chilly. Last go. No, I think the reaction's stopping there. It's cold. Right, I've got two chemicals here, and this one here in my right hand is hydrochloric acid. You can see it's an acid because it's red with universal indicator. And this one here in my left hand is sodium hydroxide, and you can tell it's an alkali because it's purple with universal indicator. So what I'm going to do is mix them together, and we're going to see, is it exothermic or is it endothermic? Let me pop those down. I'll quickly find out the temperature. This won't be so spectacular, but we should see a change in temperature. It is currently at about 20. So, not expecting fireworks, but let's see what it does. Give it a quick stir. Can you see different colours? Still a bit of acid up at the top. Still a bit of alkali at the bottom. And if we get it all mixed round, should roughly... Oh, that's fairly neutralised. Oh, a little bit acid. It's not exactly neutralised, but fairly close. Temperature is now about 25. So we can see that is exothermic. Energy has left the chemicals and it has gone into the thermometer and is now 25. More mixing chemicals. If I pop that thermometer in there, this is just pure water. And this one here is a salt. It's not just any old salt, it's called ammonium chloride. And it's really soluble. It dissolves very quickly. Dissolves much better than normal salt does. But it is still just salt. So really, we're doing salt and water. Let's have a look. Let's pop it in. Oh, temperature first. The temperature to start with is 20. And it goes. Give it a good old stir. Right, let's have a look. Right, that has dropped to about 11 degrees. So it's dropped by about 9 degrees. That's endothermic. It has absorbed energy. It's absorbed energy from the thermometer and from the test tube and the air and sucks it all up. Maybe it's dropped down to about 10 degrees. Endothermic. Got colder.